There is one interesting observation that I would like to share with you, which will be quite useful to you in case that you don't have a table with you for the areas of reinforcement. Let us look at the columns of 2 units of reinforcement bar and the 3 units of reinforcement bar. You will see an interesting pattern here. Let's say 3 units of 16 mm diameter bar. If you have issue with the spacing, you may increase the bar size while providing 2 units of reinforcement. The provided bar area will be slightly larger than what is required. Under most circumstances, it is applicable, except for the case of 10 mm to 12 mm diameter reinforcement bar. Now, in terms of the applications in the beam, industrial practice will have minimum bar size of 12 mm for all the beams. That means you can do a simple conversions from 3 units of reinforcement bar to 2 units of reinforcement bar by just adding up one size of the bar, such as 3 units of T12 to 2 units of T16, or 16 to 20, 20 to 25, 25 to 32, 32 to 40. You will see the amount of reinforcement bar, it will always be slightly larger than 3 units of reinforcement. Now coming back to this case, having two options here, either 4 units of T16 or 2 units of T20. In this case, we're going to choose 2 units of T20 as it consumes slightly less reinforcement bar than providing 4 units of T16, giving us a new arrangement of the reinforcement bar on 2 T20 at the support and 2 T25 at the mid-spec. You're going to repeat the process of checking the actual spacing. Get the width minus 2 times of cover minus 2 times of the link size minus 2 units or 20 mm bar, and your actual spacing now is 53 mm. Checking against the minimum bar spacing requirement, your actual spacing is now greater than the minimum bar spacing. Then you know that you have no issue with the minimum bar spacing. With that said, we can proceed with the curtailments of the reinforcement. Based on the simplified rules of the curtailments, you can reduce the amount of reinforcement bar at the regions which is not necessary, with the conditions that the amount of reinforcement bar provided must be greater than the percentage indicated here. In this case, you have 2 units of rebar at the bottom and 2 units of the reinforcement bar at the top. Industrial practice, you will need a minimum of 2 units of rebar on top and 2 units of reinforcement bar at the bottom. You cannot simply cut one of the bar from the 2T20, nor you can simply remove one of the bar of 2T25 at the regions that you can do the curtailments. These 4 units of the reinforcement bar here are required for the tying of the shear link, one at each corner of the link. While having this setting the minimum amount of reinforcement bar, you cannot stop this 2T20 at any areas here, as this region will still need reinforcement. That give you a logical arrangement of the reinforcement bar, extending this 2T20 towards the end support, as well as extending this 2T25 to the supports without any curtailment. Only that this is going to be quite wasteful, especially at this region here, you don't need that much of reinforcement. An additional reinforcement provided, it would be a waste. This leads to another solution here, what you often see in the industrial practices. They're going to stick with 2T20 at the support, as you cannot simply reduce the amount of reinforcement bar here. However, at these regions, you only need 20% of the reinforcement. What they do, they reduce the bar size by providing 2T12, which is equivalent to 35% of this 2T20 reinforcement bar area. Since you are changing the bar size in order to ensure continuity between two bars here, so that stress can be effectively transferred from one bar to another, you will require a lapping length. Now, Eurocode provide guidance in terms of the required lapping length. It is very much dependent on the region where it is good bond or poor bond. Now we are talking about the top reinforcement bar, which in accordance to the Eurocode, this being has a height of 600 mm. The top region here, it will be the regions of poor bond. That means if you are lapping the top reinforcement bar here, it will be in the regions of poor bond. You will need a greater length for the lapping. Let's say now you've done the calculations, the required lapping length, it will be about 50 times the bar diameter. Now the issue here is whether this diameter is referring to 12 mm diameters or 20 mm diameter. Let me explain the principles here. When you are lapping two reinforcement bar of different sizes, the lapping length it will be governed by the bar with the smaller size. Why is it so? Because you are talking about transferring the stress from one bar to another bar. One bar is bigger size and one bar is smaller size. If you are lapped together, which bar do you think that it will fail first? Of course, the smaller bar size it will fail first due to smaller bar area. And then what is the purpose of doing this lapping? While lapping the reinforcement bar, the longer the lapping length, the greater the bond with the concrete. The bond stress will accumulate along the length until the full lapping length is achieved. Then you can guarantee full stress of the bar are effectively transferred. Since now the smaller bar size will govern the capacity, you will only need to provide the amount of lapping length sufficient to generate full stress for the smaller bar size. Beyond that, it will be a waste. You can actually provide more in accordance to the bigger bar size. Just that later, the lapping will not fail, but the smaller bar size will fail. So in order to minimize the waste, you just need to remember the simple rules of thumb. When you do the lapping length will be governed by the smaller bar size. Now the next question here, where should you do the lapping? Should your lapping start here or start here? Or should your lapping ends here or ends here? Now you may refer to the percentage of the reinforcement here. This region represents 100% of the reinforcement bar. You are changing into 2T12, which give you 35% of the remaining bar area. That means it's fulfilled this requirement, but it does not fulfill this. In another word, there will be no argument that you're going to provide 2T20 at this region. Now the next question. Should this end here or this start here? Then you need to know a very important principle here. Among these two reinforcement bar here, which one is more critical? 2T20 is more critical. Now in the lapping region here, where do you think that it is likely to generate the full stress of the reinforcement? It will be at the end of the anchorage leg. That means you will expect the full stress develop here, and you will have zero stress developing here. Therefore, you cannot have the lapping start here. You should have lapping ends here. This will be the right arrangements of the reinforcement at the lapping region. Now, having this determined, you know that the required lapping length is 50 times the diameter. Follow the diameter of smaller bar size that give you 600 mm. And the lapping should end at the regions where you can do the curtailment. Now your next thing here, it will be finding this location. Since this one is no longer be relevant, you can ignore this part. Leaving you these two value here will govern the final locations of this. Based on the description here, you will choose the bigger value of the two. First is 0.25 L. The L represents the effective span between the supports, which is 6 meters in this case. 0.25 times of 6 meters, that gives you 1.5 meter. And then it is stated that it needs to be at least greater than 45 times the bar diameter. Now this bar diameter, is it referring to T12 or T20? T12 is not relevant to this. That give you your bar diameter here is referring to T20. Ultimately, it will be equals to 900 mm. Choose the bigger value of the two. Then you know that the locations here, it will be at 1.5 meter from the surface of the interior support. By changing the bar size towards the support here, you can reduce the amount of reinforcement by 65%. Normally, industrial people, they do this. How about the bottom reinforcement bar? Will you do the same lapping the reinforcement bar here by changing the bar size? Normally, we don't do that. Why is it so? First, you have only 2 units of reinforcement bar here. Second, the region here is relatively short. By using the principles of doing the bar lapping starting here, that means if you want to reduce the bar size, your lapping will have to start here. And this is likely will be the lapping regions here. When this is relatively short and you need to provide lapping, it is very likely ended up more or less same amount of reinforcement bar here. But it gives you additional work. You need to measure the reinforcement bar and cut the reinforcement bar and doing lapping at the specific regions here. While doing lapping, you may have issue with the minimum bar spacing, which at the end of the day, it is not really practical to do so. Therefore, in this case, we will just stick to 2T25 throughout the bottom reinforcement bar along the spec. As a wrap up for this example here, normally in the design of reinforcement beam, you do calculations, determine the amount of reinforcement bar, and then you propose the arrangements of the reinforcement bar, check the minimum spacing, make sure it passes, and then you do the curtailment. The final arrangements of the reinforcement bar may not follow strictly by the simplified rules of the curtailment, as these simplified rules give you the minimum amount of reinforcement bar area. You can provide more but not less. Being constrained by the requirement that you need at least 2 top bar and 2 bottom bar here. In this case, after you've done the curtailment, it may end up either this one or this one. Both are correct, except that this is less economical. Now, if you are concerned with the cost of the materials, you can reduce the bar size at the support by doing the lapping of the reinforcement bar. Make sure you provide sufficient lapping putting the lapping in the right place. Where should it start and where should it end? And also determine the right places in accordance to the requirements by the simplified curtailment rules. And then later in the detailings, you need to indicate clearly the required lapping length as well as the locations where the lapping starts.